Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Younger Dryas, Evolution of a Hypothesis. The Earth was coming out of an ice age during a warming trend when suddenly, 12,900 years ago, global temperatures dropped and returned the Earth to glacial conditions during a period called the Younger Dryas. All the megafauna, or large animals that inhabited North America, became extinct at about that time. After 1,200 years of frigid weather, global temperatures increased as suddenly as they had decreased and Earth's warming trend was restored. Scientists have proposed various hypotheses to explain the Younger Dryas cooling event and the disappearance of the large animals. One hypothesis proposes that fragments of a disintegrating comet impacted the Earth, killing the megafauna and triggering a global winter. An early version of this hypothesis also suggested that the Carolina Bays had been created as a result of the extraterrestrial impact. A scientific hypothesis provides an explanation for natural phenomena, but the explanation must be testable by experiments. If a hypothesis cannot be tested, then it is not a scientific hypothesis. This is why the Younger Dryas Impact Hypothesis has faced so much antagonism. It cannot be tested. Even if it were possible, we would not want to test an impact so large that it would destroy our civilization. For this reason, this hypothesis can only be accepted by other scientists if there is enough supporting evidence to prove that an extraterrestrial impact did in fact occur, and that it was large enough to have caused an extinction and a global cooling event. The idea that cosmic impacts created the Carolina Bays was formally presented in a paper published in 1933 by Melton and Shriver from the University of Arizona. The authors considered the elliptical shape of the bays, their parallel alignment, their raised rims, and the fact that overlapping bays maintained their elliptical shape. All these characteristics were unlike those produced by terrestrial processes. The arguments for the impact origin of the Carolina Bays were countered by proposals for terrestrial mechanisms. In 1942, Douglas Johnson proposed a complex mechanism that involved artesian springs combined with the action of wind and water. In 1954, C. Wythe Cook suggested that ocean eddies shaped the bays, and in 1977, Raymond Koszorowski conducted experiments that tried to form elliptical bays by the action of the wind. In 1982, Henry Savage published a book that recounted the long-fought battles between proponents of celestial impacts and proponents of terrestrial processes. In his conclusion, Savage sided with the celestial group and made a suggestion for further research on the Carolina Bays that will be discussed later. The first incarnation of the Younger Dryas Impact Hypothesis came in 2006 with the publication of The Cycle of Cosmic Catastrophes by Richard Firestone and Alan West. The chapter on the Carolina Bays starts by noting that many scientists believe that the bays formed not from impacts, but from wind and water action alone. The authors then ask the question, what evidence is there supporting the impact theory? They answer that one of the strongest arguments supporting the impact theory is that the bays seem to be unique on the entire planet, and whatever process formed them is not creating any new bays. In other words, if common agents like wind and water had formed the bays instead of an impact, then wind and water should still be producing more bays at this moment somewhere on vast land areas of our planet. In 2007, Firestone and 25 co-authors proposed that an extraterrestrial impact caused the extinction of the North American megafauna and triggered the Younger Dryas cooling event. This paper reported microspherules and nanodiamonds at the Younger Dryas boundary as evidence of an extraterrestrial explosion over North America that destabilized the Laurentide ice sheet and caused extensive biomass burning. The Carolina Bays were not included as evidence of the extraterrestrial impact because by this time it was known that the bays had different dates and thus they could not have formed at the time of the proposed impact. In 2010, Davies and Gilbride determined that Saginaw Bay was the convergence point of the Carolina Bays and the Nebraska rainwater basins that share the same elliptical geometry. The authors used great circle trajectories adjusted for the Coriolis effect to calculate the convergence point. In addition to the convergence work, Michael Davey has established a publicly available LiDAR database that is a great resource for research on the Carolina Bays. In 2015, Zamora published the book Solving the Mystery of the Carolina Bays, showing that well-preserved Carolina Bays were perfect ellipses. Since ellipses are conic sections, the book suggested that the bays had originated as inclined conical cavities. The book described experiments that actually produced single and overlapping elliptical depressions with raised rims. Experiments demonstrated that impacts on a viscous surface are plastic deformations that restore the stratigraphy by viscous relaxation. The problem of the diverse dates was resolved by showing that only the surface of the new conical cavity is exposed to sunlight during the formation of the bay, and thus testing of the subsurface by optically stimulated luminescence can only determine the date of the terrain, but not the date of bay formation. In 2017, the Glacier Ice Impact Hypothesis was published in the peer-reviewed journal Geomorphology. The paper described 4 mechanisms that explain the formation of the Carolina Bays. First, a meteorite impact on the Laurentide ice sheet ejected ice boulders. The secondary impacts by the ice boulders liquefied on consolidated ground close to the water table. Oblique impacts of ice boulders on liquefied ground created inclined conical cavities, and finally, viscous relaxation reduced the depth of the conical cavities to produce shallow elliptical bays. The paper proposed that the saturation bombardment by the glacier ice boulders caused an extinction event within a radius of 1,500 kilometers from the impact point, and water ejected above the atmosphere produced a fog of ice crystals in low Earth orbit that blocked the light of the sun and triggered the global winter. The Glacier Ice Impact Hypothesis has not been challenged yet in a peer-reviewed publication. Previously, I mentioned that Henry Savage made a suggestion for further research on the Carolina Bays. In page 96 of the Mysterious Carolina Bays, he says, "Near Camden, South Carolina, is a long farm drainage ditch with a depth of about 14 feet. Exposed at the bottom of the ditch are masses of prostrate timbers, many of considerable size, indicating a massive blowdown. If those logs show a carbon-14 date corresponding to the birth of the bays, we would have a dramatic curtain racing on a day of disaster like no other in the history of man." This is a LiDAR image of the region near Camden, South Carolina mentioned by Savage. Most of the Carolina Bays are in the coastal plain, and it is not easy to see any bays near Camden. I discussed the book by Henry Savage with Chris Cottrell, who has the Dabbler's Den channel on YouTube. Chris has a background in geology, and he took the challenge of finding the Carolina Bay with the deep ditch mentioned in the book. Using Google Earth with a LiDAR image overlay, we can zoom in on a bay with a deep drainage ditch that is very likely the bay mentioned by Savage. This bay near Camden is at an elevation of 90 meters above sea level, compared to an elevation of 60 meters for the abundant bays on the coastal plain. From the heavy erosion in the adjacent terrain, it is very unusual that this bay at a high elevation has been preserved. It is likely that the meltwater from the glacier chunks that impacted nearby eroded the soil, leaving only the current bay and the surrounding dendritic terrain. In this image, the bay is overlaid with an ellipse to demonstrate that the bay has the characteristics of a well-preserved bay in spite of its isolation. The ellipse is semi-transparent and slightly smaller than the bay to evaluate the goodness of fit. The inset has some of the characteristics of the bay, including its geographical coordinates and its elevation above sea level. The length of the bay's major axis is 964 meters or 3,162 feet. From the width to length ratio, we can calculate that the bay was formed by an impact inclined at 41.6 degrees. It is assumed that Saginaw Bay is the point of origin of the ice boulder that made the bay. Using Google Earth, we can measure the distance to Saginaw Bay as 1,101 kilometers. Knowing the angle of impact and the distance, we use ballistic equations to calculate a launch speed of 3,299 meters per second and a time of flight of 446 seconds, which is 7.44 minutes. Power laws relating energy to crater size estimate that the ice projectile that made the bay had a diameter of 220 meters, indicated in this image by a yellow circle. The crater formation time was 7.24 seconds. The impact energy was 3.03 times 10 to the 16th joules, or 7.23 megatons of TNT. And George Howard, who publishes the CosmicDusk.com website, provided me with an article from 2005 by Professor David Stahl about ancient bald cypress forest buried in South Carolina. It is not difficult to imagine that the saturation bombardment by secondary chunks of glacier ice ejected by an extraterrestrial impact on the Laurentide ice sheet could have flattened forests and buried them in mud. The report by Professor Stahl says, bald cypress is known as the wood everlasting and has been recovered from buried deposits of great antiquity. In fact, the famous 18th century botanist William Bartram described the buried subfossil cypress forest exposed at the base of a 100-foot-tall riverbank on the Mississippi River near Port Hudson, Louisiana, in 1977. Here in the cliffs we see vast stumps of cypress and other trees. These stumps are sound, stand upright, and seem to be rotted off about 2 or 3 feet above the spread of their roots. Their trunks, limbs, etc. lie in all directions about them. The Port Hudson site was revisited and confirmed by Carpenter in 1838 and by the great 19th century geologist Sir Charles Lyell in 1846. Brown and Muntz in 1986 report a single radiocarbon date of 12,520 plus or minus 410 years old for a stump exposed at the site in 1953. This date coincides with the cataclysm at the onset of the Younger Dryas cooling event, estimated at 12,800 calendar years before the present. The description of the Port Hudson, Louisiana site in Professor Stahl's report is reminiscent of the landscape in Tunguska, Russia, which was the site of an explosion attributed to the airburst of a meteoroid in 1908. The Younger Dryas Impact Hypothesis provides us with a new perspective for interpreting the masses of prostrate timbers in South Carolina and the ancient cypress forest buried in Louisiana. We will continue our work until there is overwhelming evidence that the megafaunal extinction and the onset of the Younger Dryas cooling event were caused by an extraterrestrial impact. We just calculated that a single Carolina bay of 964 meters was formed by a glacier ice impact equivalent to 7.23 megatons of TNT. This image shows a landscape completely covered with Carolina bays, many of which are much bigger than 1 kilometer. It is evident that no fauna could have survived the onslaught of the impacts of glacier ice in a wide region of the United States. The buried forests that we are beginning to explore are silent witnesses of this catastrophe. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.